In this video, we'll do some implicit differentiation. So we're given this equation here, and we're asked to find the derivative of y with respect to x. So this is something I've done many, many times. I don't recall ever actually explaining my work to anyone. So we'll see how this video goes. If you have any questions, feel free to email me or drop a comment below. But here's how I think of problems like this. So I've got this happy little equation, and I want to find the rate of change at any given point on this, on the graph of this. So I can't really isolate my y very neatly, so I'll just do some implicit differentiations. The first thing I'll do is I'll just find the derivative with respect to x of each side. So let me choose a color here. I'll do it in, we'll go orange. So I'll do the derivative with respect to x of the 4x cubed plus 3y cubed, all raised to the fifth, is equal to the derivative with respect to x of 2y. As we can see here on the right side here, there is no x term, but we can think of y as a function of x. So how I like to think of this side in my head is by doing this. I'll go over here. That's equal to, I do the derivative with respect to y, derivative of y with respect to x of 2y. So I think of this notation just like with fractions. Any factor divided by itself is 1. That's how I process this. So this simplifies, this d derivative with respect to y times derivative of y with respect to x simplifies to d dx. Essentially, this divided by this is 1. It's still the derivative with respect to x there. So I break it up like that. On the other side, and I guess starting on the right side here wasn't the best idea to work this way now. I'm going to find the derivative with respect to x of this. And the inside part here is going to be a function raised to the fifth. So I'm going to have to use chain rule. So I'm going to find the derivative with respect to x. Let's say it's like, I don't know, of g of x all raised to the fifth. Well, that would be 5 times g of x all raised to the fourth, but I still need to find the derivative of the inside part. So I'll do this part first. And again, if something in my explanation is not making sense, please ask for clarification. I'm happy to help. I'm going to start way over here. I don't know how much room I'll need, but I know this is going to be long with chain rule. So chain rule says I'm going to have 5 times this base. It's basically power rule here is all I'm using. So I have some base raised to a power, so my exponent becomes the coefficient outside. I keep my base, which is 4x cubed plus 3y cubed, all raised to the fourth. I subtract 1. The chain rule says now we need to multiply this by the derivative of what's inside. We're going to multiply that by d, well actually this part I'll just do, the derivative with respect to x of each of these terms. So the derivative with respect to x of 4x cubed, again using power rule, is 3 times 4, which is 12. Then x, subtract 1 from the exponent there. That's going to be squared. Plus, now I do the same thing I did here with this. And I'll write that part out. So it's going to be the derivative with respect to y times derivative with respect to y compared to x of 3y cubed. And that's equal to this. So far all I've done is used power rule, and I've used chain rule, and I've thought of derivative with respect to x as derivative with respect to y of dy dx for the parts of this equation that don't have an x term in it, but they aren't constants. They aren't constant terms, I should say. All right, so now I play with this a bit more. This first part here, I am not going to expand this out. I'm going to leave this in factored form with exponents. I think it's going to look a lot nicer. So I still have the 5 times the quantity of 4x cubed plus 3y cubed raised to the fourth. inside, I'm going to have on the inside, in the next part here, I have still the 12x squared, and I'm going to do the derivative with respect to y of 3y cubed times dy dx. So derivative with respect to y of 3y cubed, those 3 times 3 is 9. Y, subtract 1 from my exponent, again just using power rule here, is squared. But I still have this dy dx, this rate of change happening at any given point on the graph of this, which I don't know, that's what I'm solving for. And that's equal to, now I'll do the same thing here. I'll find the derivative with respect to y of 2y. Again, using power rule, there's a 1 right there as an exponent, so 1 times 2 is 2. And then this y to the first becomes y to the 0, which equals 1. So that's just equal to 2, but I still have my dy dx. dy dx. Now it's a matter of playing around with distributive property to isolate this dy dx to one side. So I have two terms with dy dx in it. So I'm going to want to probably distribute over here. So I'll take my outer factor, which is all of this, and I'll distribute it to each term on the inside. So multiply 5 times this quantity times this 12x squared. I'll go ahead and multiply the 12x squared by the 5. That's going to give me, I'll switch to, green looks good. So 5 times 12 is 60, so I get 60. And then x squared, that's being multiplied by this quantity of 4x cubed plus 3y cubed, still raised to the fourth. And now I'll multiply this factor by the next term inside this quantity. So 5 times 9 is 45. That gives me y squared, still times the 4x cubed plus 3y cubed. Again, not expanding this out. I don't want that many. I don't want to see that many terms right now. If I want to expand it out, I would do it in my very last step. But I really don't want to do that part. So I've done this times this factor. So this big factor, including the quantity with the exponent, times the 9y squared factor. Now I just have this dy dx there at the end. And that's equal to 2 dy dx. So this term has no dy dx in it. This term does, and this term does. So I have a couple of options here. I really don't think one is better than the other per se. It just comes down to personal preference. I could subtract 2 dy dx from both sides, get this side to 0 out. Then I could subtract 60x squared times the quantity of 4x cubed plus 3y cubed, all raised to the fourth power, from both sides. And I get 45y squared times this quantity dy dx minus 2 dy dx is equal to the opposite of this. That's two steps. I'd rather do it in one step. So instead, I'll just subtract this term from both sides. I'll subtract the 45y squared times 4x cubed plus 3y cubed dy dx from this side. This becomes a 0. And I'll subtract it from here. That's minus 45y squared 4x cubed plus 3y cubed dy dx. Scroll down, give us some more real estate to write on. Let's do lavender. So to simplify this side, I'm left with 60 x squared times the quantity of 4x cubed plus 3y cubed, all raised to the fourth, looking for copy errors and such. So far I don't see any I've made, but who knows, is equal to, now I'll use distributive property. I have two terms, a 2 and technically a negative 45y squared times the quantity of 4x cubed plus 3y cubed. Copy error. See, I did make one. I did make one. So if you caught that, excellent job. I didn't catch it. That's to the fourth power. That's to the fourth power. That's to the fourth power. I forgot to copy that exponent of 4 down. So these types of errors happen a lot when you have this much going on. You forget about something. But back to this, I have two terms. They both have a dy dx. So I can factor that dy dx out. So I have dy dx times, it's going to be 2, I'm not going to do plus negative here, I'll just do minus the 45y squared times the quantity of 4x cubed plus 3y cubed, all raised to the fourth. And don't forget about these exponents like I did a moment ago. Now we're just about done. Here's the fun part. We have a term on this side, we have a term on this side. This term has two factors, this little dy dx here, and this big old factor of this mess. But I actually forgot a pair of parentheses, didn't I? Or part of the parentheses, so it's times this. I should have closed parentheses right there, I guess. So now I'll just divide both sides by 2 minus 45y squared times the quantity of 4x cubed plus 3y cubed raised to the fourth, all divided by 2 minus 45y squared times the quantity of 4x cubed plus 3y cubed, all raised to the fourth. And this right here is what's going to equal dy dx. I don't feel like rewriting all of that, so I'll just make a nice little copy, paste, move it down, and that is what equals dy dx. So this is how I think about problems when I'm working through them. If you think about it differently, or if you think I'm making an error somewhere, or if you know I'm making an error somewhere, or I'm taking some liberties with mathematics I shouldn't be taking, please let me know. I'm always happy to learn cool new tricks or learn where I'm still making errors. This isn't something I normally do. This is just something that's still in my head from college, I guess. So keep practicing problems like this. Again, if you see any mistakes or you have any questions or just have any comments, let me know. I'm always happy to help.